Hello friends, I welcome you in lecture number 17 on hypothesis testing. In this lecture also we will discuss one question related to large sample test for a population proportion. So first we understand what is this question about. A random sample of 150, that is 150 recent donations at a certain blood bank reveals that 82 were type A blood. Does this suggest that the actual percentage of type A donations differs from 40%, the percentage of the population having type A blood? Carry out a test of the appropriate hypothesis using a significance level of 0.01. So first we have to decide what is the population and what is population proportion, and from that population what is the data of random sample. So from this question we can see that the population is the set of all blood donations. We can consider that the set of all blood donations, set of all blood donations can be considered as the population for this question. Now in this population we are interested in the blood donations which are having type A blood. So the characteristic in which we are interested is that type A blood donation. We are interested in the type A blood donations from this population, and it is given that the actual percentage of type A donations differs from 40%. So that is population proportion is different from 40%, that is 0.40. We have to check whether the actual percentage of type A donations differs from 40% or not. So this we want to check. Now here they are considering a random sample of 150 donations and find that 82 are of type A. So random sample is of size 150, and if we consider capital X equal to number of type A blood donations, from this number of type A blood donations in these samples, then it is given that X is 82. So from this we can find out the sample proportion, which is denoted by P hat, which is capital X by N, and that is nothing but 82 divided by 150, and this comes out to be 0.5467. This is sample proportion, and we have to check whether population proportion is different from this 40% or 0.40 or not. So this is what we have got from this question, the information which is given to answer this question, and we have to consider level of significance as 0.01. Now first thing we have to decide is null and alternative hypothesis, and for that we can see that we are asked to check whether actual population percentage of type A blood donations is different from 40% or not, and we know that equality part always go in null hypothesis, and therefore we assume that suppose percentage of population having type A blood donations is equal to 40% or 0.40, and here we consider that it is different from 40%, that is 0.40. So this is null and alternative hypothesis. Now level of significance is given as 0.01. Level of significance is alpha equal to 0.01. Now next step is to find out the value of test statistic. For that we know that if certain conditions are satisfied, then we can apply one sample Z test for testing hypothesis related to population proportion. So for that we have to decide what is n times p, that is 150 times 82, and let me calculate this. 150 times 82, I am doing these calculations, and I find that no, this is not 82. N is the number of observations in the sample, P is the population proportion, and we assume that this null hypothesis is correct. Therefore we consider P equal to 0.40. So 150 into 0.40, this gives me 60, and obviously it is greater than 5, and I have to check for n times 1 minus p also. N is 150 and 1 minus p, that is 1 minus 40. So let me calculate this. 150 times 0.60, this turns out to be 90, and both are greater than 5. Therefore we can apply one sample Z test for testing null hypothesis. Now what is test statistic? So test statistic is, the test statistic for this is capital Z equal to sample proportion minus population proportion divided by square root of population proportion times 1 minus population proportion divided by n. And we are having all these values now. We have calculated this sample proportion is 0.5467. Let me substitute this. 0.5467 minus, we assume that null hypothesis is true, therefore we can put small p equal to 0.40, and this is square root of p, that is 0.40, 1 minus p, that is 0.60, and sample size is 150, and this turns out to be, this difference in the numerator is 0.1467, and this becomes 0.04, this square root of this quantity, and this is equal to 3.6675, and if I round off up to 2 decimal places, I can write this as 3.67. So therefore the value of test statistic is 3.67. Now next step is to compare this value with critical values, and for that now we try to find out critical values of Z, and for that we know that the level of significance is alpha equal to 0.01, and you can see alternative hypothesis is two-sided, that P is different from 0.40. We have two-sided alternative hypothesis, that is we have two-tailed test, therefore this alpha is divided into two equal areas, 0.01 divided by 2, that is 0.005, and we know that this capital Z is approximately standard normal random variable, therefore its graph will be approximately standard normal curve, and we are familiar with the shape of standard normal curve. It is a bell shaped curve, and now this is the center of the this peak is at the center. These are the values of Z, and we are dividing area alpha into two sub areas which are equal. These are alpha by 2, that is 0.005 in this case. So we have two-tailed test, therefore we divide area alpha equal to 0.01 into two equal areas in both the tails. Area in left tail as well as right tail is 0.005, and this point is denoted by z sub alpha by 2. This is critical point here, and due to symmetry this is negative of z suffix 0.005, and I have to decide these critical values. So from this we can say that probability that capital Z is to the right side of Z suffix 0.005 is equal to this area to the right side of this point, and it is 0.005. Therefore, the area to the left side of 0.005 is equal to 1 minus 0.005, and that turns out to be 0.9950. And using standard normal table, we have to decide the value of this z suffix 0.005 such that we obtain this area or this probability equal to 0.9950. So we have to search for this value or this area in the cumulative standard normal probability table, and we have to find out the corresponding value of small z. So we now search for 0.995 in the cumulative standard normal probability table. This is cumulative standard normal probability table, and this shaded area is nothing but probability that capital Z is less than this value, and here we are interested in the area of 0.9950. So we are interested in the value of small z such that we obtain this area. So these values in the table denote the areas to the left side of this point z. All these areas are nothing but probability that capital Z is smaller than this z. So now we search for 0.9950. So here I have to search for 0.9950. So I will find out the values which are near to 0.9950, or I can check whether I obtain exactly 0.9950. Here I have 0.9951, you can see, and this is 0.9949. So we can take the average of z values corresponding to these two areas, and here this value of z is 2.5, and if we go in this row up to this, we have to search for this value. So here we can see I have 0.07, that means I have 2.57 corresponding to 0.9949, and this corresponds to 0.8. On the left side we have 2.50 or 2.5 here, and here if we consider this row corresponds to 2.5, and these two values which are near to 0.995 are related to 0.07 and 0.08. So I have to add 0.07 to 2.5, and similarly I have to add 0.08 to 2.5, and I obtain these two z values, and I have to take their average. So this is nothing but 2.575, and this we will consider as value of small z suffix 0.005. So this value is nothing but 2.575, and here we can mention that from the table or from the standard normal table z suffix 0.005, this is going to be 2.57 plus 2.58 divided by 2, and this is 2.575, and this value is negative of this value due to symmetry of standard normal curve. So the area to the right side of this point and to the left side of this point, these two areas are rejection regions. This is rejection region, and this area is also rejection region, and the area in between these 2 points is non-rejection region. Now once we decide critical values, we have to compare critical value with calculated value of test statistic, which is 3.67 here. So we have to find out the location, approximate location of z statistic value. So it is 3.67, and we can see 3.67 is obviously greater than 2.575. That means we are somewhere here. This is value of test statistic z, and it is in the rejection region. So therefore we can conclude that we have to reject null hypothesis, because calculated value of test statistic, which is 3.67, is to the right side of z 0.005, which is 2.575. Since this happens, we reject null hypothesis H0, and null hypothesis is that percentage is 40. The actual percentage is 0.40 or 40%. So we are rejecting this null hypothesis. Therefore we can say that the actual percentage of type A donations differs from 40%, the percentage of the population having type A blood. So the question is, does this suggest? So the answer is, this suggests that the actual percentage of type A donations differs from 40%, which is the percentage of the population having type A blood. So that we can write as our conclusion for this question. We can write that therefore this suggests that the actual percentage of type A blood donations differs from 40%. Differs from 40%. So in this way we can apply this one sample Z test for testing the null hypothesis related to population proportion. All we have to remember is this formula for test statistic, where this sample proportion p hat is given by capital X by n. This small p is the value of population proportion that always comes from the null hypothesis, and it is also given in the question. And n is the sample size, capital X is the number of elements in the sample which are of particular class of interest. Here the population is this set of all blood donations, and we are interested in the class of type A blood donations. So capital X will be equal to number of type A blood donations in this sample, and question was to check whether population proportion differs from 40%. So we assume that null hypothesis is that suppose population proportion is not different from 40%, that is it is 0.40, and we are testing this null hypothesis using this one sample Z test. And be careful, we must check this condition. With this condition satisfied, we can say that this z is a standard normal random variable, and if we have standard normal random variable, we can find out critical values using standard normal probability tables. So this is all about this session. I hope you like it. Thanks for watching.